Hello, in this video I'm going to talk about conditional structure in Python. The simplest conditional structure is if statement. The if statement checks a condition, and if the condition is true, it is return the result. Let's have a look. This code checks if the variable age is 18 or older and prints you are an adult if the condition is true. We have a variable age equals 18, and if age is greater equals 18, print you are an adult. And since age is 18, when I run it, the result would be you are an adult. Let's go for if-else statement. The if-else statement allows the program to choose between two blocks of code. Executing one of the condition is true and the other if it's false. This code checks if the variable age is 18 or older. If age, we have variable age equals 16, and if age is greater equals 18, print you are an adult. Else, if it's not, print you are a minor. And since age is 16, you can see the result. If I run it, it would be typed you are a minor. And if I change the 16 to, for example, 19 and run it, you can see it is written you are an adult. Let's check if-elif statement. If-elif statement lets the program evaluate multiple conditions in sequence. Let's check it. We have age equals 20, and this code evaluates the value of age, printing you are a child if you are under 13, you are a teenager if between 13 and 17, and if you are greater or older than 18, it is written you are an adult. And since age here is 20, it is written you are an adult. And if I change it, for example, to 12 and run it again, you are a child because 12 is lower than 13. We have nested conditions. Allows you to place an if statement inside another if statement, creating layers of decision making within your code. This structure is useful when you need to check additional conditions only if a previous condition is true. Let's check it here. We have this algorithm here. We have if condition 1 is true, so check if condition 2. And if condition 2 is true, let's have a statement A. And if condition 2 is false, go for a statement B. And if condition 1 is not true, so it is false. If it's false, let's check if condition 3. And if condition 3 is true, we have a statement C. And if condition 3 is false, go for a statement D. And for example, the final result is a statement X. So it checks some if layers and then achieve the final result. We have age, variable age equals 20, is a student, true. If age is greater equal 18, if a student is true, it checks two conditions. First, the age condition is being checked, and then if it's about 18, then the next if is being checked. If it's a student, print you are an adult student, else print you are an adult. And this else refers to that if. It means that if age is under 18, print you are a minor. So depending on the age, the result would be different. We have age 20 here, and if I run it, you are an adult student because it checks 20, it's greater than 18, and then check is student, it is true, so it is written you're an adult student. And if I change it, for example, to 15 and run the code, we see that the first if is not correct, so it goes to else and print it you are a minor. We have multiple conditions. So multiple conditions allows you to evaluate more than one condition at the same time using logical operators like and or not. For example, this code checks whether both conditions, being 18 or older and being a student, are true, and if so, it prints you are an adult student. We have variable age equals 20 is a student is a true, and the code if age is greater equals 18 and is a student, it means that if is a student is a true, print you are an adult student. So when I run it, I see that it is written you are an adult student. And if I change it, for example, to 17 and I run it, we can see we have no result because we haven't mentioned any else for it. So let's check ternary condition operator. Ternary condition operator in Python is a shorthand way to write an if-else statement in a single line, which is sometimes is necessary. The code checks if age is 18 or older. If true, it assigns adult to status. Otherwise, it assigns minor and then prints the result. We have variable age equals 20, status equals adult. If age is greater equal 18, otherwise or else, please return minor. And it put minor or adult into a status and print a status for us. When I run it, the result would be adult since age is 20. And if I change 20 to, for example, 14 and run it, the result would be minor because the age is not older or equals 18. Let's have a look for assert. The assert statement in Python is used to test if a condition is true. If the condition is false, the program will raise an assertion error, which can be helpful for debugging by ensuring certain conditions hold true during execution. It's commonly used to catch bugs early by verifying assumption in the code. In this very short example, the assert statement checks if x is greater than 0, assert x is greater than 0. If this condition is true, the program continues to execute and the print x is positive. And if the condition is false, the message would be x should be greater than 0. So when I run it, the result x is positive. We have list comprehension. List comprehension is a concise way to create lists in Python, and it allows for more readable and efficient code compared to traditional loops. Let's have a look here. We have variables number equals 1, 2, 3, 4, 5. It's a list, and we want to squares x exponent 2 for x in numbers if x remainder 2 equals 0. And if I run it, it just written 2 exponent 2 4 and 4 exponent 2 16, and 1 and 3 and 5, since the remainder is not equaling 0, they are not counted here. For this type numbers, we have a list of 1 to 10, 1, 2, 3, 4 to 10, and The code, the above code, uses list comprehension to create even numbers. A list containing only the even elements from the original number. So I have even numbers, x for x in numbers if x remainder 2 equals 0. So 2, 4, 6, 8, and 10 would be the result, as you can see here. List comprehension with nested conditions. List comprehension with nested conditions lets you apply multiple filters or transformations to list element in a single concise line of code. We have variables numbers equals a list of 1 to 10, and even or odd equals even if num reminders 2 equals 0, else print odd or show us odd for num in numbers, and then print the variable even or odd. And when I run it, you can see the result. 1 is odd, 2 is even, 3 is odd, and it shows us the result. And let's go for match case. Match case is a feature introduced in Python that allows for more readable and structured decision making through pattern matching, similar to switch case statement in other languages. If you are familiar with other languages, you can easily learn it. In this example, we have variables command equals start, and I want to see that whether I can match it or not. Match command case start, print starting the process. If the case is stop, print stopping the process. If the case is pause, print pausing the process. And if the case otherwise, not start, not stop, or not pause, print unknown comment. And when I run it, since the command equals start, you can see that case start, print starting the process. And if I change it, for example, to stop and run the code, stopping the process.